I'm going to take a moment to go ahead and talk about how to do transformations generally with just basic generic notation. We're going to have a common notation here, which is a f of b times x minus c plus d. And each one of these, a, b, c, and d, are all going to do something different to the function that we have. The one thing you do need to know is that the f right here, this is actually our parent function. So if I have something like, I want to say f of x equals 1 over x, which is what we're leading up to, this f right here is going to be this function 1 over x. So not terribly complex. What's really nice about this notation is that this f could be any parent function, such as f of x equals x squared, maybe f of x equals the square root of x. The only thing that really changes in this equation is the f right here. That's going to depend on the parent function that you're told that you have. The a, the b, the c, and the d all are going to do the exact same thing to every single parent function. So let's take a look and see what those a, b, c, and d actually do. Okay, so let's look at each individual letter. Let's start with the letter A. So with the letter A, the A is going to affect your y values. That means it's going up and down. So everything is going to be vertical when it talks about A. When the absolute value of A is greater than 1, what's actually going to happen is if you have a function, it's going to actually stretch vertically like so. So we're going to stretch it vertically like so. So the graph is actually going to get a little skinnier. If the absolute value of A is less than 1, that means if it's like 0.5 or 1/2, 1/3, 2/3, something that is less than 1, what will actually happen is your graph will shrink and it'll get a little fatter. So if you can kind of see here, it's shrinking and get a little fatter. If the absolute value is less than 0, basically if you have a negative number, if you have a negative A, what that's going to do is it's going to reflect over the x-axis. So we're going to go reflect it over the x-axis going this direction because it's changing the y values, which are going up and down, so as we reflect. So let's take a look at B. Now B in this case, in Algebra 2, there's not going to be a lot of functions that actually have a B, but there are some. You'll deal mostly with that when you get to pre-calculus or the upper level maths, when there's an actual B. However, when we deal with B, there are still some basic rules, but it gets a little bit more confusing. If the absolute value of B is greater than 0, it's actually going to be a shrink. It's actually going to be a shrink of a factor of 1/2. So what happens is it's going to affect your x. So you would think if the number is greater than 1, it would stretch, but in reality, it shrinks it down. Now, if the absolute value of B is less than 1, it's actually the stretch. And then this is really the only one we're going to deal with in Algebra 2 is if we have a negative, just a -1 or a negative B, it's actually going to, because it changes the x values, it's going to reflect over the y-axis like so. So from here to here, it's changing the x values, not so much the y values. All right, so let's look at C. C also affects the x values, meaning it's going to change horizontally, but C is going to be my translation. But you need to remember, though, in my original equation, it was x minus c. So in this case, when my c is greater than 1, I have a horizontal translation right. So whenever it's a positive, my c is a positive number, I want to move right. So I'm going to move things to the right. When my c is less than 1, I'm going to take everything and shift it left. Now this is rigid motion, meaning it's not going to change the shape of the graph like A and B do, because A and B will either make it skinnier or wider or longer or shorter. But that's just moving it left and right. What you have to remember is left is going to be negative, positive, right is going to be positive. But there's a caveat to this when we start working the problems, and you'll see here in a second. Last but not least, let's talk about D. D affects the y values. That means it's going to be going vertical up and down. And this is my translation. So whenever my D is greater than 1, it's going to move it up. So if I have a function here and it's going to be greater than 1, I'm going to move it up, my D. If it is less than 1, it's going down in the negative direction. So these are our basic transformations. It doesn't matter what parent function we have. A, B, C, or D are going to do all the same thing. The only thing that's going to change is where we start from with our parent function itself. So let's look at an example.